Okay, this is expanding and factoring expressions. This is coming from your student handout 2. So everybody should be turned to student handout 2 in their binder. And the very top of the page should look like this. Alright. We are going to be simplifying the following expression by following the order of operations. So you see here on number 1, I left all the work on it. And there's a couple ways that you could solve this. You could add the parentheses together, 3 plus 9, get your 12, then do 6 times 12 to get your 72. That's one way of working it. The other way of working it is distributing this 6 and multiplying times the 3, 6 times 3, and the 6 times the 9. 6 times 3 will give you 18. Then your 6 times 9 would give you your 54. When you add 18 and 54, you should get your 72. So really, in this instance, it doesn't matter which way you wanted to solve it. Each way is working out because there's no variable involved. They're all regular constant numbers. And you have this guy on the outside of a parenthesis, he's just called a distributor. So I have a constant and a constant, so 2 terms and a distributor. So here I could do 9 plus 2 and know that that's 11, so 5 times 11. 5 times 11 gives me 55 and be done. I could have done 5 times 9, get 45. 5 times the 2, get 10. 45 plus 10 gives me 55. Got the same answers either way. Here I could do 8 minus 4, get 4, times the 2, give me the 8. Or I could do 2 times the 8, get a 16, minus 2 times the 4, and get an 8. 16 minus 8 gives me 8. Either way, I'm always getting the same answer. So here it says, how is 2 times x plus 2 different? Brainstorm how this problem could be simplified. Okay, using what we just thought about up here, it's not fully simplified. How could I fully simplify this? Pause the video and talk with your peers for about 30 seconds to see what you think, and play the video. Okay, the answer that they are saying is, see if it opens here, the variable x has been replaced with a number. That's what a variable does. The process will remain the same. You would just distribute that 7 to both terms. And I could have gotten even simpler and gone 7x plus a 14 if I simplify that all the way out. So you're using the same process, but whereas this method was kind of quicker doing the parentheses first, we couldn't do the parentheses because we don't know what x is. They're not like terms. So since they weren't like terms, I couldn't combine them. I had to just distribute. That's all I could do. So we're going to talk more about the distributive property. The distributive property allows the number outside of the parentheses to be distributed to the terms inside the parentheses. With the distributive property, I kind of like making a rainbow with it. Here's my distributor. I like to make a little nice rainbow to every term, and the rainbow just means that I am multiplying each term by the distributor of a 3. So 3 times 2, 3 times 7, then I would simplify. Or 3 times x, 3 times a positive 7. Then you could simplify from there. That's the distributive property. You're distributing a number. So let's play around with the distributive property. It says each of the 4 members of the Robinson family ordered a drink, D, 2 slices of pizza, P, and an ice cream cones. Okay, everybody ordered that. There was 4 members. So I can basically have the distributive property. I had 4 sets of drinks. 4's getting distributed to the drinks. Everybody got 2 slices of pizza. So this is understood to be a D right now. Right now I have 2 slices of pizza. But all 4 members are getting 2 slices, so I need 4 sets of 2 slices. So it'd be like having 4 sets of all these 2P's. But remember, mathematicians are lazy, so we didn't want to have to write these all the time, so we came up with multiplication. And then we had 1 ice cream cone, but each person got 1 ice cream cone, and 4 people of the family each got 1. So I need to distribute this 4 to see what total items I had here. So basically this turned out looking like 4 sets of drinks plus 4 sets of 2 pizzas plus 4 cones. I'm distributing this 4 to every term in the parenthesis. Distributing means multiply. So 4 times D. There's an understood 1 to be in front of variables. So 4 times 1D is 4D. 4 times 2P. 4 times 2 is 8. So I have, my bill is added, I have 8 more pizzas. Then 4 times, this is a plus, so I'm bringing a plus down. 4 times, there's an understood 1 there, so 4 times 1 is 4 ice cream cones. So after I distribute, I get my simplified expression here of 4D plus 8P plus 4C. Some people will want to add all these numbers up. Well, I can't. Those are drinks, pizzas, ice cream cones. Those are different items. You can't add them up. I could combine all my 2P's because all those were pizzas. That's one category. So instead of me having to write writing out all these D's plus 8 of these P's and so forth, I was able to write it out simpler like this. I don't want to sit there and write all that. I'm lazy. Alright, we're going to use distributive property using a area model. Well, to find area of a rectangle is length times width, right? So here's my length, here's my width. I have 2 different widths. So this is kind of like just a distributive that we just looked at. The 5's getting distributed to the 3x and the 2, or length times width, 5 times 3x. Well, what is 5 times 3x? 5 times 3, I need 5 sets of 3, so I could write all that out, or 5 times 3 gives me 15x. Then length times width to find here, 5 times 2 gives me 10, so a plus 10. This is just showing it in an area model. I think more algebraically with these parentheses and such, but some people see it better as an area model. If that's you, you could always use this method. Put your terms in some rectangles. Same thing here. I do length times width. 7 times x, this is understood to be a 1, so 7 times 1, 7, so that gives me 7x. I keep the variable. 7 times a negative 9 gives me a negative 63. So my final answer would be 7x minus 63. These are unlike terms. They don't have the same last name. So that would be your final answer. Alright, flipping to the back side. I'm going to do a few problems here. I'm going to do number 4. And I have just regular old distributive properties. I'm going to distribute. I have 2 terms inside my parentheses. I'm distributing my 5 out. So I could sit here and write 5 times 6x plus 5 times 9. But once we get really good at it, we don't have to write that. We could kind of see it in our head. 5 times 6x is 30x. I have 5 sets of 6x. Well, that means I would have had to write 30 x's. I didn't want to write 30 x's, so I used my multiplication instead. Then I need 5 sets of 9. There's a plus sign in between it, so I'm writing a plus sign. 5 sets of 9. I don't want to write all those ones, so I'm going to use multiplication. 5 times 9 gives me 45. I notice that these are unlike terms, so this is as simplified as it can be, so my final answer is 30x plus 45. Okay, I'm going to do number 8 next. Here I notice that there are 3 terms inside the parenthesis. My distributor is an 8, so everybody is getting multiplied by the distributor of 8. Okay, so I could sit here and write it all out, but math people are lazy. So I have 8 times p, that's understood to be a 1, p. 8 times 1 is 8. Got to keep the last name. It's like they're getting married when they multiply. Got to keep the last name of the p. 8 times a 7 gives me 56. And then I have 8 times 2q. So I need 8 sets of 2q's. Well, I don't want to write all those q's, so I'm going to use multiplication. 8 times 2 gives me a 16. Taking the last name of the variable, q. So I notice I have 3 terms here, so I'm going to ask myself if any of them are alike to combine them. Last name's P, last name is constant, last name is Q. So they're all different, so they cannot be combined. So that would be my final answer. Okay, I'm going to number 10. Wants me to simplify the expression using the distributive property, then combine any like terms. Okay, so I have a term, 2 terms in the parenthesis, a distributor, then I have a constant outside the parenthesis. That means the distributor is not going to multiply times that constant. So The distributor is just being multiplied to the parentheses. So I have 6 times 4c gives me 24c. 6 times remember the sign in front goes with it. That's a -2. 6 times a -2 is -12. Now it looks like a -12. Same difference. -12 minus 12, same thing. That's why they look alike. 6 does not multiply this guy. He's not in parentheses. So I'm just going to bring him on down with the rest of the group. Now, you always have to ask yourself, is there any like terms to combine? So I see last name is C here, last name is constant here, last name is constant here. So I have a constant of a -12 and a constant of a +10. So that means these two get to combine. So I know 24c doesn't get to combine with anybody. I have a negative and a positive. So it means I could write out -1 12 times, a +1 10 times, cancel them out. I would have 2 left over of negatives or positives. I'd have negatives left over, so that would be -2, or different signs subtract. 12 minus 10 is 2. Keep the sign of the larger number. Larger number is negative. -2 or -2. Now, all together, it reached 24c minus 2 as a final answer. Okay, you're going to be working some problems here in a minute by yourself. Don't let this one freak you out. You should know what half of 8 is, and you should know what half of 6 is. Just because it's a fraction doesn't mean you can't do it. Okay, but we're not there yet. Let's move on to the next bottom part here. It says factoring an expression. Expressions can be factored to remove the common factor. This is your GCF. This is how we undo the distributive property. It's kind of like we're working backwards. So now we already have the answer. We want to work backwards and see what the problem would have been. Just makes us smarter. So we're first going to determine the greatest common factor. There's our GCF between our values. We're going to remove the greatest common factor by dividing each of the terms by it. So for our example, I have 16x plus 15. I know the greatest common factor between a 6 and a 15 is 3. Because 3 times 2 gives me 6, and 3 times 5 gives me 15. That's the greatest common factor both of these have. So I can factor out a 3 of both of these terms. So I took out a 3, then I had to ask myself, 3 times what gave me this 6? Well, 3 times 2, x, gives me a 6x. 3 times what gives me a positive 15? Positive 5 gives me a positive 15. So I worked backwards to get my distributive property. So we're going to do that using our area models here. They already found the area. So I have a 4x and a 16. I need to see what numbers are in common between 4 and 16. Well, factors of 4 is 1, 2, and 4. Factors of 16 is 1, 2, 4. I could stop there because I see a 4 here. That's the highest it could go there. So I could factor out a 4. Okay, then I would ask myself, 4 times what is going to give me 4x? Well, it's not going to be 4x because 4 times 4 is 16. 4 times what gives me 4x? Just a regular old x. 4 times x, there's understood to be a 1 there. 4 times 1x gives me 4x. Then 4 times what gives me this 16? 4 times what number gives me 16? 4. A positive 4. So I then factored. So I could have had my parenthesis set up like this. Okay, here. Find a GCF between 12 and 18. Well, we have 1, 2, 3, 4, 6, 12. Okay, here we have 1, 2, 6. I could stop. 12's not 1, so it looks like 6 is going to be our greatest common factor. So I can pull out a 6 that is in common. Okay, then you have to ask yourself, 6 times what gives me the 12? X. That would be 2x. I need a last name of 2x, so I had to include the x. Then 6 times what gives me 18? 6 times a positive 3 gives me the 18. So I worked backwards there to figure out what the problem was. That's what I'm going to do on number 13 as well, that I'm working with you. Okay, so 13, I want to work backwards. What's my greatest common factor between a 6a and a positive 2? Factors of 6 would be 1, 2, 3, 6. Factors of 2, 1 and 2. So it looks like my greatest common factor is 2. So I'm pulling out a 2, creating my parentheses. I know A's got to be here. I don't know if a number's got to be here. 2 times what gives me a 6a? Well, to make a 6, it has to be a 3. So 2 times 3a gives me 6a, so that works. 2 times what gives me a 2 here? 2 times 1 gives me 2. 2 times 1, so that works. There's my answer. Basically, can never go wrong on these problems if you just double check your work. Alright, so you have problems 5, 6, 7, 9, 11, 12, 14, and 15 to try on your own for me to sign off on and check.